Okay, good evening. So this is going to be a statistics test review for quiz 2. Okay, so what's going to be on it? What are we going to be doing? Let's go ahead and have a look at that. Let me share my screen. There we go. Where are we? We are right here. Okay. So 4 questions. Well, 4 sections. I can't do like parts A, B, C with you guys. I have to do 1, 2, 3. So there's like a number of questions, but there's 4 sections with a number of questions in each one of them. Okay, so that's how it's set up. You shouldn't need extra pieces of paper. We shouldn't need to upload anything. So I think everything is within the test. You can just write down the arithmetic. So if they ask you to do the arithmetic, we'll do it off to the side here so you can see what I'm looking for. One part is like a multiple choice. Okay, you need to know the empirical rule. Okay, sorry, I insist on this one. All right, so that's a memorized, right? That means in a bell-shaped distribution, right, 68% of data is within plus or minus 1 standard deviations. Okay, 95% is within plus or minus 2 standard deviations, and 99.7% is within 3 standard deviations. Okay, so that's one. You need to be able to put numbers into your calculator and generate a correlation coefficient. This is a multiple choice question. So if you think, hey, maybe I should write all of this out, like, no, that's a full question. That's like a 6-point question to do all that arithmetic, because I want to see how you say, I would want to see how you would set it up. I want to see your organization. I want to see all of that. This one just asks you if the correlation coefficient is A, B, C, D, E. I just want you to plug them into your calculator and tell me that you know how to get it from the calculator. That's it. Okay, so don't memorize how to do this. I mean, memorize how to do it on your calculator, but you don't have to memorize like this, you don't need to know this. Okay, I mean, great if you do, but don't feel like this is something you need to take to your grave or anything, because this is not an important formula for you to have memorized. I mean, unless your dream is to teach statistics someday, and I will assure you it's not as glamorous as it looks. Okay, so 3, but it is fun. Okay, you get to torture people. It's a lot of fun. I'm kidding. It's actually very rewarding. Yeah. So let's see here. We have multiple choice. We have that, and I think there's another one. Like, you remember me asking you if standard deviation could be 0? I mean, it can, but it's a really boring data set. Like that data set would have a standard deviation of 0. They're all 3. Okay. So something like that, but with correlation. So what can correlation be? Correlation be between -1 R and +1. All right, that's it. Okay, so that's the first one. Okay, it's the first section is multiple choice stuff. So, most of the stuff that I asked about, you should kind of get just by going through the problems and remembering, like, oh yeah, that's how that works. So that should be okay. The second one is about a box and whiskers plot. Now, I've asked students before to tell me what a box and whiskers plot is, but I have decided that there's a lot of work that goes into creating one of these. And while that's a great exercise to have people do, it's a great exercise to have students make a box and whiskers plot, putting one on an exam and saying, here, tie all these pieces together, that is truly a lot. And I don't like to do that. Not anymore. Okay. So I can be taught. So mostly what I do is I show you a box and whiskers plot, okay, and ask you questions about it. All right. So if we have a box and whiskers plot, of course, we're going to have a scale. Okay, so there'll be a name for it. Okay. Now, the example I happened to pick was a race. Okay. And low numbers are going to signify people who did better in a race than high numbers, okay? So I know that my 5K time is somewhere around like 30 hours. That's not very good, okay? So if you're gonna run a 5K, like 20 minutes is pretty good. 25, not too bad. 30 minutes is like, think about average. And like, if you're running 3 miles in like, closer to an hour, like that's what most people walk at, is 3 miles per hour. And if you're running at my pace, well, glaciers are going to beat you to the finish line. So there we are. So early numbers are better. Okay, we draw the box and whiskers plot. Right, that's the median. There's a Q1. There's a Q3. Okay, we'll actually do an example for this one. Okay, I found one. Found a good one. I liked it. It's like, that works. So 3.3. Okay, toward the end. Okay, toward the end of 3.3. I hate to take the last question. I really do. But sometimes that's the appropriate question to take. All right. I kind of like this one. Following table represents the number of nuclear reactors as far as January 2nd, 2013, in some countries that have one or more reactors. So it's not every country, it's just some of them. And we're just looking at like, okay. By the way, you can always find this stuff on like, I don't know where they took their particular data, but like the CIA tracks stuff like this. And you can find a CIA facts book online, and they'll have all this information in there. It's actually one of my favorite places to go get data, because first off, if we paid for it, so we're going to use it. And secondly, when you do have data like this, somebody wants to disagree, it's like, well, you can take it up with the CIA. I'm sure that'll work out well. So here we go. We want to know what the first and third quarter. Well, the first thing we want to do is we got to, and I don't do this to you, okay? I know very well that you know that 33 is a bigger number than 4, okay? So we're not going to do all of that all the time here. Okay, so the first thing I'm going to do is I'm going to start putting this in order, okay? And the way I like to do that is to make a stem and leaf plot. I don't quiz you guys on this one, but what we're going to do is we're just going to write down like how many things are in the ones column, how many things are in the tens column, how many things are in the 20s. It looks like we have to do a 30s. And then Russia was the end of it, so we don't have to do a 40s. Okay, I don't think any country has a 40 nuclear, ours might, but I don't know. Okay, so all we're going to do is we're going to say, well, there's an 18. So that's red is 18. We have a 6, we have a 4, we have a 9, we have another 4, we have a 20. Okay, so 6, 4, 9, 4, 6, 4, 9, 4, 20. We have 1, 1, 2, 1, 3. Then there's a 10 and a 2. All right. Then we have Russia with 33, Slovakia with 4, South Africa with 2, South Korea, who would have thought, 23 there, 8 for Spain, 15, it's 1, 5, 1, 5 for 15 for Ukraine, and 16, 1, 6 for Ukraine. So I'm going to, once I have this, they're kind of all sorted, sort of, like in categories. So we're going to do this one more time. But this time, we're going to be a little bit more precise, because there's a lot of things between 0 and 10, wasn't there? So what I'm going to do is I'm going to break this up into the lower ones and the upper ones. So this is going to go from 0 to 4. These are going to go from 5 to 9. This is going to go from 10 to 14. This is going to go from 15 to 19. Okay. This is going to go from 20 to 24. This is going to go from 25 to 29. And then this is going to go from 30 to 34. Okay. And this is one of the faster ways to sort. Okay, well, actually, the fastest way is to click this and say send data to Excel and press the sort button. But this is what we have. Okay, so I'm going to try to sort this in order as we're going. And with that, because we are done with just writing them down, I'm going to cross them off as I go. So we need 1, 2, 3 ones. Okay, so we're going to have 1, 2, 3. Okay. There's a couple of 2s. Okay, so here we go. There's a 2, there's a 2, there's a 2. So there's 3 2s. So 1, 2, oh. So there's 3 1s. There are 3 2s, 2, 2, and 2. Okay, how many 3s do we have? So we have a 3, and that's really about it. 3. We have to go up to 4s. Remember, we're going up to 4. So there's 1, 2, 3, 4s. All right. So it gets a little bit easier as we pare these down here. So we have 1, 2, 3, 4s. Let's go ahead and draw those in. It's going to go a lot easier after this, but we have 1, 2, 3, 4s. Okay. Now when we turn to 5, right? We get to go to a different stack. Okay. So, oops, we'll stay with blue here. Did I have any 5s? Like, no, all I have is an 8, a 9, and a 6, don't I? So that's pretty easy to sort. All right, done. When we get to the 10s, right, we have a 10, and then we have 15, 16, 15, 16, and 18. Let me change this one. Let's put a 10 in here. Okay, red 10. And then this is 15, 16, and 18. Okay, we have a 0 and a 3. Those are already in order. 0, 3. Okay, and none here. And then we have a 33. So we just leave that blank. Okay. All right. How many do we have? Some countries that have 1 or more reactors. Thanks. All right. Well, we have to count these up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Would have been happy with 19. All right. So our total is n is equal to 20. All right. And what we're going to do is we're just going to get our quartiles. Right. See, this is one of those things you're going to have to know how to do. Okay. So how do we find a quartile? We take the whatever percentage it is, right? So 25 over 100, you could skip a step and say 0.25. And then we're going to do 20 plus 1. And what does that equal? Okay. So 0.25, right? Just we can do 25 cents, right? That's what 25 over a dollar is. So 0.25, excuse me, times 21. We got 5.25. This is not the answer. The answer lies somewhere between the 5th and 6th observation. So we need the 5th and 6th observation here. Okay, so 1, 2, 3, 4, 5, and 6. So halfway between 2 and 2. That'll be 2. Okay, so that's Q1. Okay, quartile 2, this is also the median. Okay, this is 50 over 100. 20 plus 1 is equal to, right? So again, one of these, you have to know how to do this, okay? 50 divided by 100 is 21, all right? You get 10.5, all right? And so we know that the median is somewhere between the 10th and 11th data point, okay? So the 10th and the 11th data point. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the 11th data point. So we have a 4 plus 6, right? Because the 10th was 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4th. And the 6 would be the next one. It's the 11th data point divided by 2. This is 10 over 2. So 5. 5 is my quartile 2. Okay. Then we have Q3. Okay, we got 75 over 100, that's 3/4, times 21. Okay, so we're going to say 0.75 times 21 equals 15.75. So again, the most common thing that people do to make a mistake is they just put this down as the answer. It's not the answer. It's somewhere between the 15th and 16th data point. Okay. And we're going to go ahead and check that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so somewhere between the 15th and 16th data point, right? Which happens to be 15 and 16. Okay, I assure you that's a coincidence. That doesn't always happen. Okay, so this is from the table. That's where I got the 15 and 16. It has nothing to do, well, these only tell you the position in the list. They don't tell you what the values are. So be really careful about that. It's 15 and a half, okay? But that is, these are the list values. So these are the L's, and then these are the actual data values, okay? So this will be X sub 15, X sub 16, all right? If we were talking about like disease rates, like, you know, how many people had syphilis or something, it would not be 15 and 16 people like on a statewide basis, okay? I mean, Utah likes to think that, but they have a few more, okay? It's in the thousands. So it's not those numbers, it's the numbers you look up on the table that we're going to get, all right? So there we go. All right, so our first quartile, that was, what was our first quartile? That was 2. Okay, now we'll see if it makes a liar out of me. And then this one is going to be 15.5. Okay, it's a crummy problem because it's a crummy data set because it lets you do the wrong thing and still get the right answer. The median, okay, they say these data. Data is actually a plural of the word datum, D-A-T-A, D-A-T-U-M. This is the singular data. Okay, we usually say plural because there's usually more than one number. If you only had one number, it would be called datum, not data. So when they say data, it's like, that's weird. Like, it's because it's a plural word, okay? And that was 5, right? Our median was 5. All right, yay. Okay, upper and lower outlier boundaries. Now this one, I did write this formula down, but you have to know how to apply it. So the lower boundary is Q1 minus 1.5 times IQR. You don't need to memorize this formula. I gave it to you, okay? So this is Q1, which is 2, right? That was our first quartile, 2, minus 1.5, and then we need the interquartile range. Remember, this is the interquartile range, all right? And the interquartile range is Q3 minus Q1. Okay, so this is 2 minus 1.5, and we have 15.5 minus 2. Okay, and we're doing this because we're looking for, are there any observations that are unusual? Okay, so this answer is actually not going to really matter too much because it's 2 minus 1.5 times parentheses, okay, because the times is going to take whatever comes next to it and do that first. So we wanted to say 15.5 minus 2, okay? So we want this part first, right? The Q3 minus Q1, then times 1.5, and then we're going to subtract that from 2. And we're going to get negative 18.25. There are no negative nuclear reactors, okay? They can't be in debt to somebody, a nuclear reactor. It doesn't work, right? So that one, the lower boundary is negative 18.25, but usually in problems like this, if it's once it's negative, like, we're done. Okay, I'm not gonna bother calculating it. I just know that it's nonsense. It's a nonsense value. Q3 plus 1.5 IQR. This is your upper fence, upper boundary. This is your lower boundary. I'll change that to a B. All right. And again, don't memorize this formula, but you do have to know how to use it. But I have put this formula on the quiz so you don't have to memorize this thing. All right. So Q3, what is Q3? Q3 was 15.5 plus 1.5 times IQR. Same thing, same 1.5, except it's a plus because we're going bigger. And then this IQR is the same. So we're going to type it into the computer, the calculator, the same way. So it's 15.5 plus 1.5 times parentheses, okay, 15.5 minus 2. When I used to have people write their own box and whiskers plot and they messed this up, usually if they messed it up with PEMDAS, like they didn't put the parentheses, that'd usually be a much higher score that you're losing, 35.75. Okay, so what do these numbers mean? Okay, 35.75. Okay, what this means is that if there's any countries that have more than 35 or 36 nuclear reactors, we're going to say, wow, that's unusual. That's a lot. Okay. And if any country has, well, if they have a negative nuclear reactor at all, I'm going to say that's unusual. But technically, we wouldn't flag it until they had at least negative 18 nuclear reactors. Okay, so this one we don't really care because there aren't any countries that low. But this one we'd have to check. Let's look at our list. Okay, are there any countries that have more than 35 or 36? No, the biggest one we have is 33. What if there was some country that said we're like nuclear topia or something, and we have 40, 50 nuclear reactors? Well, when I drew my box and whiskers plot here, okay, we would flag that with a star. We would say that's different. It's an unusual observation compared to the rest. I'm not going to call it an outlier just yet. We're just going to say it's unusual. Okay, like, wow, that's funny. So there we go with that. We're going to check our answer. All right, they're happy. That's good. Are there any countries that are outliers? And there wasn't. I mean, even Russia was in bounds with the 33. Okay, you had to get to 36 before you said, that was weird. So, and nobody had a negative one, so that we don't have to worry about that. Okay, check your answer. All right, now, let me give you a couple more questions. Okay, we're going from 2 to 15.5. All right, so let's go ahead and do there's my line, number of nuclear reactors, nuclear power plants. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5. We have 5, 10, 15, 20, 25, 30, 35. Where's my Q1? My Q1 is here. Okay, where is my Q3? Q3 is 15, so 5, 10, 15 and a half, so about here. Okay, and then we're going to draw a little box. All right, and what's the median? The median was 5. That's convenient. Okay, this goes down to what's the minimum? The minimum is 1, so we're going to extend our whisker down to 1. And then the maximum was 33. Okay, so 5, 10, 15, 20, 25, 30, 35, 33, so about here. Okay. If there was, so we're going out all the way to the highest one. Okay, so this is 33 because that's what Russia had. Again, if there was one of 35 or not 35, but if there was a 41, we would still stop the whisker here. We would do this, and this would be outlier or unusual observation. Okay, I'm not sure in the quiz if I said it was unusual or it was an outlier. They are both, but I like to use the word unusual observation because outlier, people tend to like want to dismiss them for some reason. So I try to use the word unusual observation rather than outlier to keep people from wanting to do that. But there we go. Okay, so that would be, we don't have this one. Okay, so this isn't real. All right, I should have, here, let's put it, let's do this. Let's make it like unicorn colored so we know it's not real there. Okay, so this was a myth, just a what if case. Okay, we don't have one, but there we go. So here's a question. 5. We had 21 countries, right? I didn't do this to you. I made it an even number so that you would have an easier time with this. So let's just, oh, we do. We have n is equal to 20, don't we? Okay, we're good. Wait, is an even number. How many countries had 5 or more nuclear power plants. Well, this is the 50th percentile. So half of them, right? Half of them have 5 or more. So this is 1/2 times 20, which would be 10 countries have more than 5 or more. Okay. How many countries have between 2 and, we'll say 15. Okay, I'm using the word inclusive because I want to include it, but you can assume that inclusive, like it already means inclusive. Okay, between 2 and 15, it includes 15. Okay, because we're counting them. Okay, so how many countries have between 2 and 15? Well, 2 is the 25th percentile, right? 2 is equal to quartile 1. That's the 25th percentile. And 15 inclusive, that's quartile 3. That's the 75th percentile. What percentage is between 25 and 75? 50%. There are 10 countries that have between 2 and 15 nuclear reactors. Okay. How many countries have more than 15? Hold on, I think we have a moment here. Let's pause. All right, that's typical for cats. They had a lot of interest in what I had to say, meaning that they had 0 interest in what I had to say. How many countries have more than 15 nuclear reactors? Well, isn't 15 the quartile 3? How many is more than that? So 75% is up to that. And then what do we have left over? 25%. Okay. That's the kind of thing I'm going to be asking you to do on your quiz. Okay. Is just look at, I drew it. Okay. You don't have to draw one. I've drawn it. But just look at your box and whiskers plots. There's actually 2 of them. I'll make you, we're doing compare and contrast. Okay. But so I might have like countries in Europe versus countries in Asia. How many nuclear reactors do they have? And we'll have 2 of these little graphs for you. Okay. And all I'm going to ask you is like, which one had the bigger median? Which one had the most? Which continent had the most? Which continent had the least? For Asia or, for Europe, which country, how many reactors between 2 and 15? So you could look at the quartiles. Okay. They're all going to line up on the quartiles. The numbers are a little weird, but they're all going to line up. Okay. So I got this problem out of a book. Actually, I got this problem because my niece sent it to me. But she was on swim team. But that's what we have. Okay. So it's going to have a box and whiskers plot. You are not responsible for making an entire box and whiskers plot. All right. You're responsible for, here's a box and whiskers plot. What can you tell me about it? And there'll be some questions. I will ask you to calculate an outlier. However, I put the formulas on the question so that you can tell me what it is without having to memorize these formulas. Okay. Because you don't have enough practice to do this. And quite frankly, if you had to build one of these on your own, it's something you would look up and you would have the time to do it. So it isn't why would you need to memorize this? You have a contraption that you walk around with that will tell you the answer in about 30 seconds. Okay. So there's no reason to have that formula memorized. All right. I like you to know the empirical rule because when somebody tells you something, 95% of blah, 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 like that's between -2 and +2 standard deviations. Like it gives you some reference for those numbers. Okay, when people say percents at you or when people talk about data, okay, it gives you some idea of like where it fits. All right, what else am I going to ask you? I am going to ask you a regression equation. Let's go ahead, we can kill this. Okay, so we're going to look at this. we are going to be looking at a regression equation. All right, so problem 4.2, something like that. Okay. I didn't ask you a 4.3 problem. Okay, so if you're worried about, I used to ask those questions, but I found that they weren't really that effective. Not going to ask you this. Okay, as a matter of fact, I actually write the regression equation in for you. You don't have to be able to do that on your calculator. So if you forget, you're going to get something closer to this. Okay, I'm still going to ask you questions about it. So what's the line? We ask you that. Okay, so you're going to type this in. You're going to say, okay, well, this is y is equal to 2.02, and I kept it to 2 decimal places, plus b, which is 0.34, I'm going to say 7, okay, x. Okay, actually, I'm going to not even do that. I'm going to say 35x. Okay, which means I'm not going to answer the questions on here because they want a certain amount of decimal points, and I did not insist that you give me, like, you know, all of this. All right. So we're just going to skip this part and move on. Yeah, skip. I know you guys don't have that button. I'm sorry. Okay, correlation between the two of them. We just write down the R. Okay. R equals 0.68. What is this? This is a display least squares regression line for the price of a certain stock and the prime interest rate. Okay, so let's see here. So Y is equal to the price of stock. I'm going to assume they mean in dollars. Okay. And X is interest rate. All right, I wonder what that is. Oh, prime interest rate. So that's this is the rate, I think, at the prime interest rate. I think this is the rate that banks lend money to each other. Okay. So there. All right. What am I going to ask you about this? What does the slope mean? Okay. So remember, slopes are things like change in y over change in x. So you could say something like, for every percent increase, for every 1 unit increase, we'll say for every percent increase to prime interest rate, all right, this stock looks like it goes up, right, about 37 cents. Or 35 cents, sorry, 35 cents. Right? So $0.35. All right. Or you could say something more clever like this is the slope is the change in the stock price per the change in interest rate. Okay, so something like that. What is the intercept? So that's another question. What does the intercept mean? Okay, so that's when x is 0. Okay, the intercept is when x is equal to 0. So if the interest rate were 0, this stock price would be about $2.02 if interest rates went to 0. Okay. What if, I don't know what the prime interest rate is right now. Okay, so I just don't know that. But what if prime interest rate went to, oh, in a percent, okay. So prime interest rate went to 3%, okay? So I would want you to say, well, y is equal to 2.02 plus 0.35 times 3%. And just calculate that out. Okay, so what I'm just doing is like asking you what happens, right, if this is going on here. So we have 2.02 plus 0.35 times 3, okay? So this price would be $3.07. Right? Sounds reasonable. Okay. All right. Now the next one is, what if prime interest rate went to, give me something like ridiculous. Okay, so the question is going to have a weird answer to it, but what's a payday loan interest rate, right? What is that, like 300%? Okay, maybe more. I'm not kidding. It really is. It's really high. If you are going to payday loan people, unless it's an absolute emergency, please stop. Okay, but your price is going to be $2.02 plus 0.35. Getting the 0.35 from the rounding up here. Okay, so this is 0.346. Okay, so we're rounding up there, and we're going to type in 300. Right. I got these. If you don't know anything about economics, I got some news for you about this one. If the prime rate, that's the rate at which banks loan from each other, borrow from each other. If your prime rate went up to like something ridiculous like this, our economy is going to grind to a halt, because nobody can borrow any money at all without paying like loan shark rates. Okay. So even though this number might look like, well, that seems reasonable, no, it doesn't. Okay. If prime rate went over like what it usually does, it's low, it's like 2% or something. If prime rate went up to like 100% or 300%, okay, I think that's how you spell it. Okay, here's your word for the day, is usury. That means charging more interest than is legally allowed. All right. So payday loans, usury. Okay. Usurious is an adjective. So that's charging way too high interest rate. Our economy would crash. Okay, money would cease to have value if this were to happen. So even though that doesn't look like it looks like a stock price number to me, it does to me too. So I picked the scenario where you should be able to see like, wait a minute, this is not going to happen. So what I want you to do is like, there's going to be another part. It's comment on your answer. What I mean by comment on your answer is to give me some explanation. Like, what do you think is happening here? Why is this an unrealistic number? Okay, a lot of people, like my face-to-face class said, well, it's unrealistic. I'm like, yeah, no kidding. Why? Why is it unrealistic? Okay, I pick something that is far more common to your life than this stock. You have no idea which company this is, and probably never heard of a prime rate before, and I don't know what it is either. I know what the prime rate is, but if you ask me for a number, like, I wouldn't know. Okay, I have no idea what stock this would be. So I can't really comment because, like, I don't know. But I do know that if prime rates went to this level, like, this answer is misleading, or this answer is unreliable. 100% interest rate, prime rate is unheard of. Hold on. There we go. Okay, so 300% interest rate, this answer is unreliable. 300% prime rate is unheard of. Stock market will probably not exist. Okay. Just something to keep track of if we don't do something about our debt ceiling too. Okay, like, money doesn't mean it's money anymore. So that's the kind of thing that I'm going to ask. All right, is what does it mean? And what are the basics? I'll ask you for a calculation. Okay, but what does it mean? And what are the consequences of a weird answer? Okay, or a weird question like this. Let me see. What else did I ask you? We did a box and whiskers plot. We did we did we did multiple choice. Oh, I don't remember what it is. It is Z-squared. It is empirical rule. Okay. There's a reason I'm going to want you to memorize it, because we're going to use it. Excuse me. Okay, I think that's in 3.3. Might be in 3.2. So let's check. All right, so let's go to 3.3 again. Oh, not that one. 3.3. Let's preview this one. No. This is it. All right. Do we ask you any of the weird ones? I don't want this. Turn off. Thank you. I think we did this one in class. All right. Something like this. Okay. Question 5, 3.3. All right. So we have a fish. Okay. We have the mean length of a 1-year-old spotted flounder in millimeters is 125, the standard deviation of 13. Okay. So we have a mean is equal to 125. I'll say millimeters over here. Standard deviation of 13. And again, right? Millimeters. All right. Oh, and the mean length of a 2-year spotted flounder, okay, is, so we'll do mean of 1, and that's going to be 164. Standard deviation of 31. That's what I'm asking. Now, did they really not ask you guys some questions? Nope. Nope. That's amazing. Oh, let's check. I'll bet it's in the previous section. I'll bet it is. I always think it's z-scores, but it's actually not. This book decided it was standard deviation. Okay. We put the wrong one first. There we go. Something like, okay, sorry. 3.2, question 8, that looks good. All right. Question 7 might be really good to look at. Just saying. Yeah. So our average amount spent on lunch was, our mean was 46.05. All right. Sorry for the length of the video. This is the last problem. It has 3 parts, but we'll be able to go there. Okay. And we're going to assume that it's a bell-shaped amount. Okay. So what percentages were between these two? Okay. Now, I don't know about you, but I can't tell like how far away standard deviation wise these two things are. Okay. I mean, from by inspection, you can kind of guess, but you know what I'm going to do? I'm going to say Z is equal to X minus mu divided by sigma. I think I give you this formula. If not, I mean, yeah, it's there. You're going to memorize this formula before the end of the class anyway, so you might as well do that. But it is there. It is written down for you in the exam so that you can see it. Okay. And what we're going to do is we're going to try this out. So what are we doing? We're doing what? 46.05. Okay, and 3.02. Okay. 3.02. We're going to do 46.05. What is with me tonight? Over 3.02. Okay. And we're going to type these numbers in. Okay. So amounts between 4303 minus, okay, and then 49.07. 49.07 minus. All right. And we're going to calculate these out. So we're going to take 4303 minus 46.05 divided by 3.02. One guess. It's -1. All right. What about 49.07 minus 46.05? Let me warn you that not all of the problems are nicely symmetric like this, okay? So just because you got 3 on one side doesn't mean you're going to get 3 on the other side, all right? So be careful. Many problems in the book do have it symmetric, which is nice, but I'm not nice, okay? So we're going to go from -1 to +1. What percentage of the data is within one standard deviation? 68%, okay? That's something you're going to have to memorize. You're going to have to know, okay? I didn't ask you, like I didn't make it cute with like how many were there. I just said what percentage, same as the book did, okay? So we want approximately 68%, okay? Because we know it's within one standard deviation of the mean, okay? Now let me ask you, okay, I think this one's symmetric, and I think this one's symmetric. The next one will be symmetric. So let's ask you something more interesting. What percentage is more than 43.03? Okay. One of the ones I did ask you is symmetric, so it's not like these are totally unseen. Okay. I just went and carried it. The next section in the homework does like a little bit more of this. So it's -1, right? If the z-score for this guy here was -1. So if we know that there's 68% here, how much is outside of this little shaded part? Okay. So we have 100% in total to spend. We're going to minus 68% because we've already accounted for that. How much is left? That would be 32%. Okay. So I've got 32 cents. I got to put it in 2 pockets, but it's got to be even. So isn't there 16% here and 16% in this case? So if I just want to know how many people spent more, that would be all of the shaded stuff over here, right? That would be the 68%. Okay, let me write that a little bit bigger. That would be the 68% here, plus the 16% that is this spot up here, right? Because it's bigger. All right, and then we are going to get 84% spent more than $43.03 in a week for lunch. Okay. Okay, is that right? All right. So that's the kind of thing I would ask for that one. Let's see. Let's try the next one. Actually, let's just do one of them. Let's just do 55% or $55. Okay. Okay. Minus, what do we have? 46.0305. Right, because that's our average. Where am I getting that number? From the beginning scenario. Okay. Divided by 3.03, 3.02. Okay. And again, where did I get it? From the original scenario, 3.02. So we're going to take our 55.11 minus 46.05 equals, that's going to be a little boring. I was hoping this would be a 2 standard deviations, but instead it's 3. Okay, so that's plus 3. We're going to check the other side just in case, okay? So we need to check 36.99. So we have 36.99 minus 46.05 over 3.02, okay? So like I said, the book, they tend to be, a lot of them are symmetric, but not all of them. So please double check. Okay, if you've ever worked selling shoes, you know that not everybody's feet are the same size, right? The left foot and the right foot might be a different size. I think that only matters to athletes, but it's something you have to keep into account. Okay. So notice that they don't give us a percent, they just say almost all. That's how your book tells, that's how your book says 99.7% is almost all. And that's pretty good. Okay, so that's what we'll pick. And between which two values are approximately 95%? That's a good question. Between which two values are 95% of the data? Okay, remember the 95%. This is between -2 standard deviations and +2 standard deviations. So what if I take my mean and I add 2 standard deviations, or I take my mean and I subtract 2 standard deviations? What would that look like? All right, so we're going to take our 46.05 plus 2 times, and this was 3.02, I believe. Sorry, I covered it up. 3.02. And we're just going to type that in the calculator, okay? So 46.05 plus 2 times 3.02. Okay, 52.09. What about the lower half? So that's going to be 46.05, right? That was their mean, minus 2 times 3.02. Okay, so we're just going to type that in. 46.05 minus 2 times 3.02. I get 40.1. 40.1. Okay, $40.01. Okay, so we know that that is going to be between $40.01. Okay, oh, I want 01. All right, and $52.09. All right, and oh, I have to move this up because I have to check it. All right, so that's, yeah, I'm almost disappointed I didn't ask this question. Actually, I am disappointed I didn't ask this question. I asked you another one that we did up here with, you know, like before 36. Like how many people, what percentage of people did it before or spent less than $36.99? That's the kind of question I asked. And I'm a little sad I didn't ask this one. Okay, so there is our there is your quiz. Okay, so order is multiple choice. Oops. 2 was the last one we did. That was the empirical rule. 3 was a box and whiskers plot. And 4 is the regression. Okay, so remember, you need to know empirical rule. Okay, you need to know how to calculate a correlation coefficient in your calculator. So a calc question correlation coefficient. Again, I'm pretty sure I put down the z-score, but we're going to use it more. So you might want to know the z-score. Okay. And I don't think there was any other formulas I asked you for. Okay. Or any other, like you have some familiarity with the words. Like if I ask you for like calculate the upper fence, okay, using Q3 plus 1.5 times IQR, would you know how to apply this to the numbers that were given to you? Okay, that's the kind of thing I would want to know. All right, so how to get the IQR? I think I even put this one down as Q3 minus Q1. But getting the upper, like, where do I do this for the Q3? Like, I didn't ask you that. Okay, I only asked you for like, here's the given plot and here are the numbers. Figure it out from the numbers. Okay, so I don't make you guys draw this thing out, so I don't have to worry about like, well, did one person get this number and the other person got that number? I've given them to you. Okay. Oh, you want to see a neat thing? Go check out Wikipedia for percentiles. I mean, if you want to completely geek out on this, there's actually like a couple of different ways to do it. They're all recognized by the National Institute of Standards of, how do you want to do it? But there's like 4 different ways. I mean, you can have a whole fight over this. I mean, don't, because again, they're all recognized by this. But there's a reason why doing it by hand, doing it by calculator might give you slightly different answers, because there are 4 different recognized ways of calculating these things. They do agree for certain numbers of things, but every other time, like their percentiles could be a little bit off depending on how you did it. Okay, so if you're into fun stuff like is Emacs versus Vi. Okay, so if you know what these words are, okay, you're an old person, right? But that's the kind of stuff that will happen there. All right, so good luck with it. Okay, we have multiple choice, empirical rule. Practice these. This is probably the hardest question on the exam. Okay, box and whiskers plot. So here's the box and whiskers plots. Go ahead and tell me some things about it. I've asked you some questions. Regression. Here's the regression line. I put that on there. Go ahead and tell me some things about that regression line. Okay, so that should be a pretty straightforward exam, I hope, and we'll see. Okay, so good luck, and it's up for you. So let me know. Well, you don't have to let me know, but it should all be done. You shouldn't have to submit anything. It should all be on the quiz. So just go ahead and take it. Oh, when I asked you, like, hey, show me the calculation, what I want to see. Okay, what did we do? We did one of these while we're up here. Okay. Something like this. Okay. And I said, show me, is it an outlier or not? Okay. All I want to see is like Q3 plus 1.5 times IQR. Okay, so all I want to see is like this 15.5 plus 1.5 times parentheses. What is it? 15.5 minus 2 equals, and at that point, you can do the arithmetic. Okay, and show me what you got. Don't mess with the editor. You don't have to. I mean, you can if you want to try, but frankly, it's more trouble than it's worth for a problem like this. For what I'm asking, you don't need the math editor to make the fancy equations. Just type out the numbers, okay, and in the operations, and you'll be fine. Okay, there's no square roots, no weird powers. Okay, we're not doing anything like that. Just type those out, okay, in the written response, and write your answer in there. Okay. So good luck, and I think you'll be okay. Practice these, especially practice these. The more you can find of these, the better. All right, we'll be out. I'll write you an announcement. All right.